Question on parallelism and perpendicularity. So the first question says, determine if AB, that is line AB, is parallel or perpendicular to line PQ in A of coordinates. So question 1, A of coordinates. So A of coordinates 4, 7, B of coordinates 6, 8, P of coordinates 3, 5, and Q of coordinates 5, 6. So to know whether they are parallel or perpendicular, so we look for the gradient of line AB. So we use M1 for that. So M1 equals to Y2 minus Y1 all over S2 minus X1. So from AB, so we have X1, Y1, X2, Y2. So Y2 is 8, so 8 minus 7 all over 6 minus 4, so which is equals to 1 all over 2. So M1, which is the gradient of line AB, is half. Then M2 of PQ equals to Y2 minus Y1 all over S2 minus X1. So Y2, here is Y2, X2, then X1, Y1. So we have Y2, that is 6 minus 5 all over 5 minus 3, so which is 1 over 2. So you can now conclude that since M1 equals to M2, which is equals to half, then line AB is parallel to line PQ. So that is option A. Then number 2, question number 2, show that AB is parallel or perpendicular to PQ. So A is of coordinate minus 1 minus half, and B is of coordinate 2, 3, then P is of coordinate 5, 4, and Q is of coordinate 6, 7. So we have X1, Y1, X2, Y2 for line AB, for line PQ, X1, Y1, X2, Y2. So M1 of AB, that is the gradient of AB. So we have Y2 minus Y1 all over S2 minus X1. So Y2 is for line AB, that is 3 minus 2, then all over 2 minus 1. So which is equals to 3 plus 2 all over 2 plus 1. So we have 5 all over 3. So the first gradient, which is gradient of line AB, is 5 over 3. Then the gradient of line PQ, so M2 of PQ equals to Y2 minus Y1 all over S2 minus X1. So what is Y2? That is 7 minus 4 all over 6 minus 5. So which is equals to 3, which is equals to 3 all over 1. So 3 all over 1. So we now you can see that M2 and M1 are not the same. So you can now say M1, so let's test for perpendicularity. So the two lines are not parallel because our M1 is not equal to M2. So our M1 is not equal to M2, they are not parallel. So let's test for perpendicular. And the condition is M1 times M2 must be equals to minus 1. So what is our M1? M1 is 5 over 3 multiplied by M2, that is 3 over 1. So which is equals to, so we have 5. So 5 is now equals to minus 1. So it is not perpendicular as well. So it is not perpendicular and it is not parallel. So it is slanting line. So it is not parallel, so slanting line, slanting lines to each other or to one another. So number three. Question three says, show that the line 3y minus 5x plus 2 equals to 0 is parallel perpendicular to line 6y minus 10x minus 30 equals 0. So the first one is to get the gradient of the first equation. And to get the gradient of the first equation is to make y the subject of the formula. So it's going to be 3y minus 5x plus 2 equals 0. So 3y equals 5x minus 2. So divide both sides by y, so by 3. So we have y equals to 5 over 3x minus 2 over 3. So if you now compare this with y equals mx plus c. So the m1, which is the gradient of the first equation, that is m1 equals to 5 over 3. So that's the gradient of the first equation. Then the second equation says, so the second equation is 6y minus 10x minus 30 equals 0. So make y the subject of formula, we have 6y equals to 10x plus 30. So we divide both sides by 6. So we have 6y over 6 equals to 10x over 6 plus 30 over 6. So we have y equals 2 here 5, 2 here 3. That is 5 over 3x plus 5. So this is, you compare this with y equals mx plus c. So the second gradient, that is the gradient of the second equation, m2, is also 5 over 3. So you can see that m1 equals to m2, which is equals to 5 over 3. So since the two gradients are the same, you can now conclude that equation, therefore, equation 3y minus 5x plus 2 equals 0 is parallel to to 6y minus 10x minus 30 equals 0. So the answer is C. B, option B. Then number 4. Question 4 says, determine if y equals to this, y plus 2y, 2x, y plus 2x plus 1 equals to 0 is parallel or perpendicular to 2x minus 4y plus 3 equal 0. So from equation 1, make y the subject of formula. So y equals minus 2x minus 1. So compare this with y equals mx plus c. So m1 equals minus 2. Then the second equation, that is 2x minus 4y plus 3 equals 0. So transfer 4y to the, so 4y equals 2s plus 3. So divide both sides by 4, by 4, by 4. So if we divide through by 4, we are going to have y equals half x plus 3 over 4. So if we compare this with y equals mx plus c, so you can see that our m2 is what? M2 equals to half. But m1 is what? M1 is minus 2. So m1 and m2 are not the same, but we are going to test for the perpendicularity, so they cannot be parallel to each other. So m1 multiplied by m2 must be equals to minus 1. So m1 is minus 2 multiplied by m2, 1 over 2. So which is equals to minus 2 over 2. Minus 2 over 2 is minus 1. So you can now say since m1 times m2 equals to minus 1, then uh, y plus 2x plus 1 equals to 0 is perpendicular. So this is the symbol for perpendicular. It's perpendicular to 2x minus 4y plus 3 equal 0. So this is option, that's number 4, option A. So they are perpendicular to each other. Then number 5, question 5. So question 5 says, determine if 2x, so 2x minus 3y plus 1 equals to 0 is parallel or perpendicular to y equals 2 over 3x plus 4. So equation 1, make y the subject, transfer 3y, so it will be 3y equals to 2x plus 1. So divide both sides by 3, 3, 3, 3. So y equals 2 over 3x plus 1 over 3. So if we now compare this with y equals to mx plus c. So m1 will now be equal to 2 over 3. So the gradient of the first equation is 2 over 3. Y, the second equation, is already expressed. So that is y equals 2 over 3x plus 4. So if we compare this with y equals ms plus c. So from equation 2 is already in form of y equals ms plus c. So m2 will now be equal to 2 over 3. So you can see that the gradient of the first equation, which is 2 over 3, is the same thing as the gradient of the second equation, which is also 2 over 3. So you can now conclude that since m1 equals to m2 equals to 2 over 3, then 2x minus 3y plus 1 equals to 0 is parallel to y equals to 2 over 3 2 over 3x plus 4. So that is option B. So they are parallel to each other. So that is that on. So that is that on the solution to the given question. Thank